Unprofessional Engineering. My name is James. With me?
Well,
Whoa, interrupted. With me
you got
is...
Luke.
I do got Luke.
You do got Luke.
But we also have someone else today.
We do.
Back again, our special guest, the founder of BoXZY, Joel. Joel, how's it going today?
It's going pretty well.
That's awesome.
Founder. That
Founder.
sounds very official.
It makes me feel bad about what I've accomplished in life.
Which is...
It should, James.
Which
It's
is,
pretty much nothing. Yeah,
which is not much.
Right.
Okay.
Yeah,
okay.
so that's great. So today we brought Joel on because we're going to be talking about CNC machining, making chips. I think that's what people that do that stuff say.
It is?
I think, give or take,
That's literally the only way I judge whether I've done a good job or not.
is if you're making chips.
Making chips.
Okay.
Yeah, and loud squeaking sounds. Those are...
Okay.
They're crucial
They're
to the
opposite, I
process.
guess.
Oh, okay.
Yeah, I would think that's the bad thing.
Yeah, that's the bad
screeching
thing.
Sounds.
So
okay.
I guess as like a little teaser, the reason that we brought you on is because BoXZY is able to actually do CNC machining, cutting aluminum, brass, all sorts of fun stuff. But also, newly found out to me, it can also cut steel and maybe even titanium.
Oh, yeah, not just maybe.
No.
Okay, so...
Okay.
Oh, wow.
So, all right, so I had to do some website examples, and I wanted to develop some projects that show what kind of materials we were able to do.
Okay.
And so there were the obvious ones that we knew really well how to get done, and that was like that was aluminum, brass, plastics, wood, and I was like, okay, well, so I'm going to give. I did some difficult materials like copper, and then I realized, well, if I can do copper, which is a really difficult metal to CNC mill, because I was using bus bar, not like millable copper.
That means nothing to me, but
Same.
go ahead.
Electric bus bar is like it's electrical contacts.
Oh, okay.
Okay.
All right, so it doesn't have some of the materials you need to mill it well and
Okay.
easily. So I was like, why don't I just try some of those speeds and feeds on steel and titanium? And it turns out that they worked pretty well. Someone was sitting next to me, and he's like, "Oh, Joel, you should also turn up the speed of your speeds and feeds so that it should move really fast over the surface." And I was like, "No, BoXZY can't do that. Like we can't push it like that. We're not
Right.
like a Tormach or something like that, or a Haas." And it turns out that in fact we just use the speeds and feeds directly out of Fusion, and we are using high-speed machining speeds to cut through steel, and we actually had to do that because we couldn't get the proper chip load without it. And so the exciting part is that means that I can make a sword.
A
on BoXZY.
sword.
I did, in fact,
More
make a sword on BoXZY.
accurately, a master sword.
If I knew we were going to be on camera today, I would have actually brought the sword in and pulled it out.
It was pretty
That
cool.
would have been very dramatic.
It would have
You
been.
wouldn't? I'm a dramatic guy.
You are. There
I'm
is
good
that.
with So when you say speeds and feeds, I'm a little dense when it comes to CNC. What's the speed and what's the feed? So one is the material moving and one is the speed of the head, or what's the, for our audience that isn't
So-
into CAM or CNC all that
So there's
much.
like you have your spindle speeds, right?
So that's how fast
Yeah,
the
so
bit.
yeah, it's how fast the bit moves about its axis,
Okay.
right? And then you have like your feeds, which are they tell you how fast you're moving over the material through the material. So like if it's moving on the X and the Y axes, it'll be moving laterally one direction or another at some speed. Like
Okay.
BoXZY was moving at 2 inches per second
Okay.
through steel.
Is that fast? 2 inches per second?
seems fast.
It
For a
seems
hobbyist
fast,
device?
But for a hobbyist device,
Yeah.
that's moving.
And so we actually were really struggling because we have better specs mechanically than any hobbyist device. And so we were trying to figure out a way to actually prove it in a way that didn't just say it, because everybody makes claims that they can't mechanically back up. And so everybody's got the claims out there. So we were actually having trouble selling our claims.
Okay.
So what we proved was that we can do what a really big machine can do that no other hobbyist device can do, and that is plow through steel and titanium and copper and all the other soft metals.
Okay, so let's back up a little bit.
Okay.
So back to the basics. So CNC stands for apparently Computer Numerical Control Programming. Seems fair enough. So that's the programming that goes into making the machine do what it does.
Yep.
How do you make that code?
So what we do, we have a special output from Fusion 360. It's the BoXZY.cps code.
So a special code inside of the CAD CAM program.
Yeah.
Okay.
So inside of so after you do your CAD modeling design, your object design, you point out which features that you want to be machined in specific sorts of ways, and Fusion and other CAM profiles will develop a toolpath, and then you just output that toolpath, and it outputs as G code.
Okay, and so the G code is then
Is just you hit
what you upload to the machine somehow?
Yeah, you
and
upload
then-
it directly to BoXZY and you hit print.
Okay, cool. So how does it know? Like, this is one of the parts I'm always intimidated about. It's one thing if I put in one tool, it cuts the thing away into the shape I want it to be, we're good to go. Now, in your code, you have to allow for changing tools, right?
Mm-hmm.
So how does that work? How often are you changing tools? It seems scary. They're moving fast. They're getting hot. How does that work?
It's actually pretty easy. So on BoXZY especially, so the way that you do it, the way that I do it at least, there are other ways, but I output. So what I do is after each mechanical operation, I take different sets of G code. So like if I want to drill holes, I'll have like a drilling operation. If I want to cut a profile paths, and it has a different bit, I'll set a different operation. Right?
So those are different bits that you're using to drill
Yeah.
the hole, to do the surfacing, to do anything.
Yeah, so they would be different bits. Like you might use an 1/8 inch bit for your profile pass. You might use a 1/4 inch bit to surface the material.
Okay.
Right. So each bit gives it, of course, a new ability. So like a 1/4 inch bit,
Like a superhero.
like a superhero.
Okay.
Yeah.
And is changing that bit physically like I'm thinking of like my drill bit, like there's a chuck.
It
Right.
is just like changing out a drill bit.
Okay.
Okay.
And the only thing that you gotta keep in mind is that you have to let the computer know where it is, and keep where the machine is and where the computer is aligned.
Okay.
And all that requires is that you return the machine to this point of origin.
The zero
Zero, zero, 0 point.
Gotcha.
And then you put the bit in, and at that point you make sure your Z height is set, so your vertical height, and all you do is set that off to the top of the material,
Okay.
and that gives you allows you to change the
I
bit.
feel like I could do this now, James.
So I don't know about that. I might need a little hand holding.
Well, so what's great is
Again, I'm scared.
Well, yeah.
you guys know that I started in philosophy and psychology.
Right. Which makes
Which
perfect
if
sense.
not- yeah, at least
That's a whole different podcast.
yeah. So, I mean, mechanically, I wouldn't have said that I was very inclined. Turns out I am. rather
Turns out you were
mechanically
wrong.
inclined.
You found
But-
that out about yourself.
Yeah,
You got
but I
deep.
destroyed BoXZY. Like, I have BoXZYs where I messed up, where it plunged through all the platform
Oh, no.
and started eating the machine itself and things like that. I have machines where I set up the G code wrong, and it dove through the 1/4 inch aluminum into our platform and through the support structures, and then it pulled across the entire plate, and then just started spinning, and it was vibrating so hard it fell off of the of the table.
So this was
That
one of those
is
unattended
awesome.
runs. and you
Well,
came back.
I ran away from it to get something, and I made a lot of people
So
angry.
that doesn't seem smart in the first place.
Yeah, so I'm saying, like, it is really easy because what I did there on so many levels was not smart. But then I just picked up the BoXZY and I started again.
Right.
The BoXZY that fell off the table.
You just picked it up, set it
drilled to the
back down.
platform, destroyed the material, and all I had to do was put it back up there and
Okay.
start again.
I love it, which is great because I'm here like, oh, convince people that it's simple and it's easy and nothing's going to go wrong. He's like, no, I pretty much blew up my BoXZY. Sorry about that.
I think the good thing is it sounds like they're pretty durable. So if I do mess it up, it's like, so I have a 3D printer. I'm not going to mention the brand because we don't do that, but
You don't?
yeah. Well,
If they send us money, we do.
well, if they send us money,
Okay.
Well, I don't know if they want me to say what I'm going to say,
Oh,
so I won't say it. That's why it's a
okay.
bad thing. So I have a 3D
Ah.
printer that it's literally been shifting since the day I got it, and it's basically tighten the belts, and it just so the build quality of something like this, I imagine, to be able to machine titanium. I mean, this thing's got to be. I mean, 3D printing for you. This is something else you guys do.
Yeah.
By swapping a head, right? I imagine that's. I mean, if you can machine titanium, 3D printing's got to be a breeze for you guys.
Yeah, oh yeah. So 3D printing doesn't really have any forces applied, so you just have to make sure that it's got good tolerances.
Okay.
Right. And so the ball screws give us that. The durability allows us to maintain those tolerances and the sturdiness of the machine, so you don't have to constantly keep resetting the belts like you would on, say, like a printer bot.
Gotcha.
not that PrinterBot's a bad 3D printer. It's a great for its cost, but it wouldn't be able to maintain where the machine understands it is and programmatically and where it is mechanically. It's not able to maintain that point.
Yeah.
That overlap.
Gotcha.
The way that BoXZY is, because BoXZY is just so over constrained.
All right, so let's take a step back here, and I know I keep coming back to the tools and the cutting mechanisms, things like that. But for people that are trying to get started with this, like at one time I was before I got scared away, what's the difference? So I'm guessing bigger tools you can cut more stuff with, maybe. Why would I use one versus another? What if I'm trying to do something very delicate? Are there very small tools I use for that? And do you actually have any brands that you would suggest people start out with, or that you really like?
Yeah, if you're going to start off with cheap Chinese bits.
Cheap Chinese bits.
Yeah, buy them in bulk.
Is that the official name?
Cheap Chinese bits.
Okay.
Buy carbide end mills. Start out with carbide end mills, and just get a whole bunch of cheap ones. Work out some rough speeds and feeds.
Because they're going to
move
break.
on up. Yeah, and then you go and you start looking at the tolerances of different bits, and you'll start to be able to see trends among what bits are good and where to get them. I don't know any specific brand offhand because I buy so many cheap Chinese bits.
Okay, that's fair.
So I have two follow-up questions to that. So the bits themselves, what's the difference between a cheap bit and an expensive bit, and what should I expect as a user for how long one is going to last versus the other, all things being equal?
Yeah, so a cheaper bit will break more easily. It won't have the same tolerances.
Okay.
It won't be, the specs won't be as refined. They'll snap all day long on forces that you wouldn't have on a better bit. And they will, when they get superheated, a lot of times they'll just, they break, the material breaks down.
Okay.
The molecular structure seems to break down much faster on cheap Chinese bits.
Gotcha.
Okay.
Good bits will. Gabe from Tech Shop gave me a bit, and I was expecting, there's not that much difference in material grades, but the same bit that Gabe gave me from a really quality source, and that had been spec'd out in the right ways, and the same bit that was from a Chinese manufacturer that had the same names like Carbide and
Yep.
Same dimensions. His bit plowed through steel for days.
The same bit.
Yeah, same bit.
Okay.
My bit, so I went through 4 of the same bit for the Chinese manufacturers.
Did you post that video online? I think I remember
Oh,
you doing
you-
a video of it breaking.
Oh yeah, if you're watching the videos on Facebook, you see me breaking so much. As a matter of fact, what's really funny is, so I am not a machinist by any means.
You're a philosopher, by
I am, yeah. So I mean, I know stuff now, right? I'm no expert on machining itself, but I know where we stand for hobbyists and kind of like that realm of knowledge. I have enough there, but if you watch me on those things and you read the comments below, there are machinists like, I've been a machinist for 25 years, and if I walked in on you doing that, I would fire you.
I saw that. Yeah. I think that was shortly after somebody reached their hand out and held the part
Yes,
down
me.
as it was being machined.
Wow.
So, yeah, he's like, there's no excuse for not having safety, which I love, by the way. He cared about me.
That's true.
And the example that I was setting for other people.
That
But,
restored your faith in humanity, right?
yeah, a little bit.
I thought so. That's beautiful. So
that.
right there, let's take a break. There's a lot of excitement. We have a lot more to talk about, but we're going to take a break for a word from our sponsor. And I think it's only fair this week that BoXZY be our sponsor,
I feel
right?
like you guys have to be, and that
So-
means we need 5 of them for free.
5
next week.
free BoXZYs by
free
next
BoXZYs.
week. But here, go give us a 15-second commercial. And go.
BoXZY is awesome.
Wow. Wow.
So, I mean, if I'm going to give my commercial,
Do it.
the steel sword says it all. Check out the Facebook.
BoXZY.com?
It is BoXZY CNC.
BoXZY.
So BoXZY CNC for Facebook,
Okay.
Twitter. If you're going to our website, it's just BoXZY.com. That's BoXZY. I'm sure it'll be in the
Yep, it's in the description here.
And check it out. I made a sword. I made throwing knives.
Axe.
Yes.
An axe I saw. That was cool.
Yeah. Did you see me throwing?
I did.
I made a knife, I threw a knife. We blew up some Coke cans, throwing the knives, and we threw it at boards, like directly off of BoXZY, directly into drawing.
Love it. One more thing I wanted to mention. It's been going pretty well so far, Luke. If you subscribe to our podcast and send it in to us either at unprofessionalengineering@gmail.com or post it on a message or comment on our Facebook channel, you get a sweet sticker. And not only is there a sweet sticker, there's two versions of it, a square one and a bumper sticker one.
Nice.
They're almost complete. We've reviewed them and we're having our final edits done. So subscribe to the podcast, send us a picture of it, and you will get an amazing sticker.
And for the record, those of you that get this bumper sticker, the picture of me, I'm on the left, doesn't look like me at all. And James and I have been arguing about this for like the last 3 weeks.
I just saw Andy, our artist, like this podcast, so I assume he's listening, and he may modify it for you.
Okay.
We'll see.
Because I feel like the character he had was his avatar. And
Maybe you have the image that we can see it.
I have it somewhere. I'll bring it up for you later. How about that? You want to judge it, don't you?
I want to judge it on air.
It looks nothing like
How
me.
about I bring it up, and while I'm doing that, you tell me a little bit about why people are shooting liquid all over this stuff. So I haven't seen you do this with BoXZY so much, unless you're using like, what, WD-40 or something. But some machines are shooting it, and it's like blasting these parts everywhere. You can't see anything that's going on. And I feel like it's to keep stuff cool and also to get chips out of the way because they kind of get stuck everywhere. But I'm not really sure if that's the case.
Yeah, so it's all the above. I mean, so like you're both chip clearing, you are cooling, and you're lubricating, which are all very important for keeping your bit from breaking down, from keeping
the hotter it gets, the easier it breaks.
And keeping,
Is that right?
Oh, yeah. So you need that. I've been using for BoXZY, for both coolant and lubricant, I use WD-40, and I just keep spraying it. Like if I'm doing a really, really profoundly fast operation, or there's more.
You just stand there and spray it, basically.
Yeah, it depends on what you're doing and what your speeds and feeds are and how good they are. Mm-hmm. So better speeds and feeds on BoXZY will result in less like dwelling of the bit in the wrong way, where which causes friction and causes heat up. So I have to use a lot of lubricant and coolant. In that case, just keep spraying it on the part. But for some of my more better designed cam baths, I only have to spray lubricant on it and it runs through it.
So also to get the chips out of the way. That's not always necessary. When does that really become an issue?
So, I mean, like with aluminum, aluminum gums up really bad.
Okay.
And so if you don't get
because
the chips
it's
out of the way.
soft?
Yeah, when it gets hot, it turns just like gum.
Oh.
And
so literally gums up. Okay.
Gums up and it bonds to itself and makes really, really messy cuts.
So I have to ask the question. So from a speed standpoint, because I'm just thinking of initially like 3D printing takes forever, right? If I want to do a print, this thing takes hours in some cases. So if let's just say I'm doing, a 2x4 square of steel, whatever you want to say it is, how long is that going to take for me to cut? Is that like 10 minutes? Is that 5 minutes, 2 minutes, 30 seconds?
Well, I mean, so it's a much faster process to mill that piece of steel.
Okay.
You can't 3D print steel for a hobbyist or so if you're gonna have a desktop device, especially one in the $3,000 range, there's nothing that'll be able to do steel.
Okay.
Nothing. So you wouldn't even be able to do that. But 3D printing, if you just compare apples to apples, it's plastic to plastic, and 3D printing plastic to CNC milling plastic. CNC is way, 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 way faster.
I gotcha. Okay.
So you can knock off a part. So the thing about 3D printing is it creates shapes that you can't possibly do with milling, right?
Yeah.
But if you're not doing one of those exceptionally unique shapes, you don't have to waste all the time building up tiny layer by tiny layer by tiny layer. You can just cut a path and you have your parts.
Gotcha.
Sometimes you can throw off a really nice mechanical part and all you did was a profile pass and it took 5 minutes.
Gotcha.
And that same part would take you 6 hours, 10 hours on a 3D printer.
Okay.
I love it. So let's take a break again. I have the picture of myself and Luke, and I think I look pretty much like me in my picture. Look at those beautiful green eyes. I love it. And then we have Luke over there on what would be my left. So for anybody listening, if you go to our Facebook page, you're going to see the picture of Luke and myself in the top left corner. It's kind of like our profile picture.
First of all, I have one giant tooth.
So first, there is the tooth issue, which is fine. It's just a cartoon.
Andy.
But we would like to have a vote. So if anybody is listening right now, go to our Facebook page, comment, and let us know, or message us and let us know if you think Luke looks like Luke from our live streams that you could view.
It looks more like him than yours does like you.
Really? See?
Yes.
Look, what are you complaining
So
about?
you're saying his doesn't look like him?
I feel like
No, not really.
I'm a mix of James and
Justin Bieber.
I'd take that. And Greeny from Mike and Mike. I'm kind of squirrely like him in that
Okay.
picture too. But I like it.
Okay.
I think I look good.
I just feel like my giant tooth, my hairline. It's
Well,
just,
it makes it look like it's a mask of you overlaid over styrofoam.
okay.
Okay.
You know what I'm saying? Like styrofoam.
Well, I
board.
mean-
So you think it does look like me?
I wouldn't
think
say
so.
either of them look a lot like you, but
It could pass.
it looks way more like
okay,
you than
okay.
that does. Rather.
I told you it looked like you.
At least give me
Anyways,
more than one tooth.
I mean,
Folks,
you got
go ahead
a
and vote.
much higher forehead in that one.
Let's go ahead and vote. Let me know what you think, and maybe we'll get them edited. Maybe we'll just take my face off of there and just have Luke's big stupid face. So-
oh,
now my mom's going to say that I'm mean again.
I know.
Remember?
Because she's your number one
She is
fan.
as well. She should be.
That explains a lot.
So let's get back to the actual reason we're here. How about that?
Yes.
So I was told that you should start cutting with aluminum, not just on BoXZY, but anywhere. Start with aluminum and brass if you're learning. Then go to like a milled steel and just avoid stainless. So do you always avoid it, or is that once you get some hours under your belt, you can move on to that?
There are various grades of stainless that are more amenable to CNC milling, but you do start, if you're starting with metals, start with brass, I think,
Okay.
and then aluminum. The only thing I say to like brass, I find to be exceptionally easy to mill, and it's a great place to learn speeds and feeds on a metal.
Okay.
But aluminum is really, really inexpensive, and you can get a ton of scrap, and you can learn all day long on that, but it's going to be a gummy mess until you
Okay.
figure it out.
Okay, well that's fair. And so then the only difference between steel is that it's harder to cut, so you're going to break more tools. It's kind of like a learning curve
Yeah.
for each individual material.
For steel, you're gonna break a lot of bits when you first start. So, like I said, buy a lot of cheap Chinese bits. The thing about steel, it's not necessarily that it's difficult to CNC. It's that it's unforgiving if you can be off by 0.3 and you'll break the bit. So what you have to do is you have to set up more carefully. Like a lot of hobbyists like just throw a piece into the machine and just start milling. But what you actually have to do, make sure that you are you're not going to break bits for something like a hardened steel, like knife spring steel to make knives or like mechanical gears. What they're going to have to do is they're going to have to do a pocket operation on something or make a planar surface, so that they're going to have to their face or pocket, so that BoXZY has a completely level platform.
Okay.
And then they put the material in there. And if they do that, and they do that very well, and they've got their speeds and feeds correct, they should be good. But if the ranges are very small, the margin of error is very small for breaking a bit.
And I feel like sometimes it's not as intuitive as you would think it is, like you had mentioned. Like I would think just faster is always better. And I'm sure that's not the case, because I like when I think of like using a handsaw, the faster I move that handsaw, the quicker it goes through, the cleaner my cuts, there's less jerking, but that's not necessarily the case.
No.
Depending on the material, the bit, the operation, right?
Yeah, I mean, so of course there's different considerations for materials. Different kinds of materials have different, you have to consider different things, but basically what you need to pay attention to is chip load.
Okay.
Chip load.
Chip load.
Okay.
So it's how much material the bit's taking out with each revolution. I may have the definition a little wrong on that, but so it's a measure of how much material it's actually taking out. And if you don't make sure that your per tooth chip load is correct, that's where you'll have your failures. So you adjust your spindle speed and your feed rate to make the optimal level of chip load for your bit. And the people you buy your bits from typically have optimal chip load measurement made publicly available to you.
Gotcha. Okay.
So I want to take this in a different direction now. Last 5-ish minutes or so that we have here. So you're a desktop CNC machine, and the more I looked into this, the vaguer that definition got for me. So I've seen BoXZY, I've worked with it, and it's probably like how many inches? Like not
it's
even
15
yeah.
by
So
7.
that's reasonable to be sitting on my desktop. Now it can cut pretty much anything. It's pretty awesome. But I was looking at other things like Millwright CNC or Shapeoko 3. Both of these do desktop machining in what I would understand as it's little, it sits on my desktop, it cuts. But neither of them looked like they could do steel or even something past aluminum and brass. It looked like those were what you were limited to.
Yeah, you want to, for those machines, you want to be really, really conservative with the materials you use.
And now that's because of like the structure, the rigidity of the machine.
Yeah, I mean, so like you have hobbyist quality and then you have like production quality. And so what we did with BoXZY, which was actually not a very good business decision in some senses, we overbuilt BoXZY so that what we're using ball screws typically reserved for industrial machines.
I remember people calling you out about that. Like, really? Like, you're that accurate? And you were like, oh yeah, we're putting money into this.
Yeah, we put a ton of money into it. BoXZY cost us, it's actually been an advertising nightmare for us because BoXZY is very expensive to produce. We have this thick aluminum cage, and then we have industrial ball screws actuating it. And we're talking like we have a 20 millimeter thick ball screw actuating the Z and 16 millimeters on the X and the Y. And it's caged in that aluminum cage. There's not a single structural piece of plastic on that entire machine. So when we were saying that because we designed it to be a miniature industrial manufacturing piece. We wanted it to not just be like the kind of machine that a hobbyist would use and make trinkets with. We wanted it to also be the kind of thing that they could make a business with and make serious mechanical components that engineers could actually create things that were that when they milled them, it wasn't like the hacked version that a hobbyist would do. It was something that they could actually take to a larger scale.
Very cool. So the last thing, since you were talking about the Z-axis, the last thing I wanted to bring up is CNC machines can range from 2-axis to 2.5-axis to 3-axis to rarely a 4-axis to a 5-axis, or even more confusing, 3+2 axis, which blows my mind. Where does BoXZY fall?
It's a 3-axis machine.
It's a 3-axis?
Yeah, and so
it's a true 3-axis, not a 2.5. That's not. I believe you. I'm
well,
just
in
wondering.
3-axis you have your X, your Y, and your Z.
Okay.
So 2.5 would be what they're calling. So the 3-axis would for milling would be what they call 2.5D.
Okay.
As opposed to 3D because you don't get true 3D until you get up to like 5-axis machines.
I'd love to get into all the details of what all of these different axes mean, but you know what? We've run out of time.
It's
so
not
what
that
a
much
shame.
fun. It's fun, and it's also available on Wikipedia.
There you go. Go Google it yourselves. Anything last minute for you, Luke?
No, I just want to thank Joel for being here and taking some time to, for me personally, give me a little bit of education on CNC. And I've been meaning to get to the lab, and now I'm way more excited to get to the lab.
Now that you
The
have
BoXZY lab.
Yeah, and I feel like if you break stuff all the time, you really can't yell at me if I go in there and something falls.
No, when you do stuff like that, it gives me a really great example of what BoXZY, like how easy it is for fatal it is for new users to learn BoXZY, because I like the fact that BoXZY's built so robust, and you proving that when you screw up really bad, which I'm sure you will.
I would say so.
It shows an
You're
example.
worse than James.
My machine is built tough enough to handle you.
Thank you
All
very
right.
much.
So with that, Joel, thanks for joining us.
Thank you.
Hopefully we'll have you back again here
Oh,
in
for
the
sure.
not so distant future. And for everyone else, thanks for listening, and we'll see you next week.
See ya.